Good morning, students. Dear students, in continuation with chapter 4, that is motion in a plane. In the previous video, we had discussed about the basics information regarding the vector, what are vectors, and what are the properties of the vectors, how you can define a physical quantity as a vector. These things we had discussed about vectors in the previous video. Now today we are going to discuss about properties of vectors and its types. Properties of vectors. Properties of vectors and its type. So before continuing this, I want to say that, dear students, please watch the videos up to last, whatever the videos uploaded by the teachers, to enhance your knowledge, because in today's pandemic situation this is the only way to teach you. And so cooperate with us and boost up our morale to give more and more new concept to you through this mode. So dear students, the first property of vector, that if a vector is displaced parallel to itself, it does not change. If a vector is displaced parallel to itself, it does not. If a vector is displaced parallel to itself, means translation of vector does not change the vector. For example, I am explaining, suppose this is vector A, and along x-axis I had displaced this vector, this is vector B, and if I had displaced this vector along y-axis, and this is vector C, then the meaning of the vector does not going to change by its parallel displacement, or translation of vector does not change its meaning. So we can say that vector A is equal to vector B is equal to vector C. All these vectors are same. Means parallel transformation, parallel translation, parallel displacement of vector does not change the vector. Second thing is, if a vector is rotated through an angle other than 2 pi or 360 degree, if a vector is rotated, if a vector is rotated through an angle other than 2 pi or 360 degree, 2 pi or 360 degree, then it changes. It means to say that suppose this is x-axis and this is y-axis, and there is a vector A, and if this vector is rotated by an angle theta which is other than 2 pi or 360 degree, which is vector B, then the vector changes itself and vector A is not equal to vector B. Vector A is not equal to vector B. Means vector A is not equal to vector B due to rotation. Due to rotation, vector A is not equal. But suppose if we had rotated this vector with 2 pi 360 degree, the vector come again to its initial position, and in this case we can say that vector A is equal to vector B. Means if a vector can be rotated by an angle of 2 pi or 360 degree, the vector does not changes, and if the vector is rotated other than angle of 2 pi or 360 degree, then vector changes. Now the third point is if frame of reference is translated or rotated. If frame of reference is translated or if frame of reference is translated or rotated, the vector does not change. The vector does not change, but its component may change. But its component may change. Suppose one of the vector, this is x-axis and y-axis, and this is the frame of reference O, and in this there is a vector A. But now if we had changed the frame of reference, like this, x dash, y dash and O dash, then the vector not changes, but on resolving the vectors into components along x-axis and y-axis, the resolution, the angle theta may changes and its component changes, but the resultant vector A remains the same. This vector remains the same, but their components along x-axis and y-axis may change. Now next is equal vectors. Equal vectors, when two vectors are said to be equal. If the two vectors are representing values of same physical quantities are called equal vectors. If their magnitudes and directions are same. When two vectors are called equal vectors, suppose this is vector A having magnitude 2 units and it is in this direction, and vector B having magnitude 2 units in the same direction, then we can say that both the magnitude and the direction of both the vectors are same, so we can say that this vector A is equal to vector B. Negative vector. Negative vector. Negative vector. Negative vector means to say that they have equal magnitudes but opposite directions. They have equal magnitudes but opposite directions. Suppose this is vector A having 2 units in magnitude and this is vector B. 2 units in magnitude but its direction is opposite to vector E. Then we can say that vector B is equal to negative of vector A, or vector A is equal to negative of vector B. Vector B is equal to negative of vector A, or vector A is negative of vector B, because their direction is different but magnitudes are same. Next one is null vector or zero vector. Null vector or zero vector. Null vector. Null vector or zero vectors are those vectors having zero magnitude, but its direction is indeterminate. But its direction is indeterminate means you cannot determine their directions, but magnitude wise it has zero magnitude. Example, ordinary zero is not a vector. Ordinary zero is not a vector because it has only magnitude but not direction. But if two equal and opposite vectors are cancelling each other, then its value is 0, having a null vector whose direction is indeterminate. Indeterminate. Why it is indeterminate? Because due to zero magnitude. Due to zero magnitude, zero means nothing, so you cannot determine its direction. But since it is a vector, so it is called as null vector or zero vector. Now next is the unit vector. Unit vector. Next one is unit vector. Unit vector. Unit vector means any vector can be represented by a unit vector in its direction. Any vector can be represented can be represented as the product of unit vector in that direction, and magnitude of that vector is given as vector A is equal to magnitude of vector A into unit vector. If there is a vector A, then its magnitude is multiplied by a unit vector along its direction, then it gives the vector. Or you can write it as magnitude of unit vector can be written as vector A divided by its unit vector. Or you can write it as like that. Unit vector along any vector can be written as vector A upon magnitude of vector. Means if there is any vector, then there is a unit vector along its direction, which can be calculated as vector upon magnitude of vector, and it gives the unit vector along the direction of that vector. Next is unit vector along x, y and z axis. I think it is clear to you, students. Unit vector along x, y and z axis. The unit vectors along x, y and z axis can be represented as I cap, j cap and k cap respectively. I cap, k cap and so if I want to say that there is a 3 coordinate axis, look at here and try to understand. This is x, y and z axis, and suppose there is a point P in the space having its coordinate x, y and z. This is origin. Then the position of this vector called position vector, and it can be represented by this position vector r can be represented by x I cap, magnitude x I cap. I cap is the direction along x axis, y is the magnitude in y direction, and j cap plus z is the magnitude in z direction into k cap. So this is the position. This vector represents the position of point P in the 3-dimensional coordinate system, and the magnitude of vector r can be represented by x square plus y square plus z square. X square plus y square plus z square whole root. So this is about the unit vector along with x, y and z axis. Now, what is the meaning of angle between two vectors? What if I am saying that angle between two vectors, then what is the meaning of this? Angle between two vectors means to say that if two vectors are joined tail to tail, and then what is the angle between these two vectors is called angle between two vectors. So note it down, and then I will try to explain you. Angle between two vectors means angle between two vectors means the smaller of the two angles between the vectors when they are placed tail to tail by displacing either of the two vectors parallel to itself. That is 0 is less than equal to theta is less than equal to phi. Very simple, try to understand. Three cases I am considering. In this first case, the angle between vector A and vector B is theta. What is the smaller angle between tail to tail? Or if the vector is like this, suppose this is A vector and this is V vector, then if we had shifted, then the angle between A and B is this one. This one is the angle. Third case, if this is vector A and this is vector B, then the angle between these two vectors tail to tail. So parallel translation of this vector is this. So the angle is this. So here there is the tail to tail coincidence, so this angle is considered. Here vector A head and vector B tail, so this angle is not considered. We translate in such a way that tail of angle B coincides with tail of angle and this angle is considered. Now here, look at here, vector A and vector B, the head of vector A is coinciding with tail of vector B, so this angle is not considered. We translate or displace vector B in such that the tail of vector B coincides with tail of vector A, and that angle is considered as the angle between these two vectors. So I think it is clear to you, students. Now the next is the angle between two collinear vectors. Angle between two collinear vectors is always 0 or 180 degree. Angle between collinear vectors is 0 or 180 degree. 0 or 180 degree. Suppose this is vector A and this is vector B. So here theta is equal to 0 degree. Theta is 0 degree. And here it is vector A and vector B. Theta is equal to 180 degree. So these are the two cases of collinear vectors. Now there are certain physical quantities which behave neither as a scalar nor as vector. We does not have to discuss quite in detail. In higher classes you will study about tensor analysis, but at this point of time you just know the definition of tensors. There are certain physical quantities. There are certain physical quantities. There are certain physical quantities which behave neither as a scalar nor as vector, neither as a scalar nor as vector, and are called tensors, or tensor quantities. Example: moment of inertia. There are also certain physical quantities which behaves sometimes as a vector, sometimes as a scalar, like angular displacement. Angular displacement for various mode, in contrast with this, these are the tensor quantities which behaves neither as a scalar nor as vector, so they are called tensors. Example: moment of inertia. But in contrast of this, there are certain physical quantities which behave sometime. There are certain physical quantities which sometime behave as vectors and sometime as scalars. Example: angular displacement. Angular displace. This is an axial vector, but for a small angular displacement, d theta 1 plus d theta 2 is equal to d theta 2 plus d theta 1. Commutation is obeyed. So it is vector. But for large, theta 1 plus theta 2 is not equal to theta 2 plus theta 1. For large angular displacement, it is not a vector, because here commutation is not obeyed. So these things are the special things about the scalar and vectors. So dear students, that's all for today, and again I am saying that watch the videos completely. Take care, have a good day. Thank you, students.